let's take a minute to review models, addressing, protocols, and equipment before we dive into some of the heavy-duty stuff. Well, what is a model? Remember that all of our devices and protocols all sort of fit into this thing, the structure we call a model. And really it's a layered set of ideas, and at each layer you have tasks or jobs that have to be performed. So the model sort of organizes all of these ideas and tasks into one collective set that we can apply to a particular network. So it's a structure. And as I said, each one of them is organized into layers, and we have historically a whole bunch of models that we've used. So which models do we use? Traditionally we used the OSI model. It was called the reference model, and what that means is that anytime we had to compare protocols or architectures, we compared them to the OSI model, sort of as a way to be able to compare apples to oranges. In reality, we use the TCP/IP model. All of the protocols and architectures and devices fit into the TCP/IP model. And all of our standards and protocols that we use today come from a couple of organizations. Most of those protocols live in the TCP/IP model. So here's a list of our standards organizations. We have the IEEE, the ITU-T, and the IETF. And really, our lower layer protocols and standards, layer 1 and layer 2, they come from the IEEE, and anything above layer 3 or layer 3 and above comes from the IETF. And there's our OSI standard, ITU-T X.200, and TCP/IP can be found in RFCs 1122 and 1123. Well, this is why we say we use the TCP/IP model most of the time today. Here we're looking at packet captures that were done on Windows machines and Macintosh machines. And you can see that all of these protocols come from a particular suite. So we've got Ethernet, and that's an IEEE standard, but then IP, UDP, TCP, all of those come from the IETF standard. They all live in the TCP/IP model, and it really doesn't matter what kind of machine you're using, a Mac, Linux, Windows, they all use the same protocols. So the TCP/IP model. Well, TCP/IP stands for Transmission Control Protocol and Internet Protocol. We also have the User Datagram Protocol. TCP and UDP live at layer 4, and IP is at layer 3. The model itself is 5 layers. So we start down there at the bottom. We've got the physical layer, and we work on our way up through the link layer, and then internet layer and transport, and then into application. Now, it really doesn't matter what model you're dealing with, whether it's the OSI or even an AppleTalk or IBM. We all have the same functions, right? We have to take electrical impulses in at layer 1 and move them on up and turn them into protocols and then into presentations that the user can see and use in an application. The functions are all the same, but the names are changed and the protocols that we use differ. So here's a comparison of them. On the left here, we've got the OSI model, and we can see that's a 7-layer model, and we see how that maps to the TCP/IP 5-layer model. Now, there's a couple of name changes, but again, the functions are largely the same. Operationally, we can sometimes get away with saying that we have a 4-layer model, and that's because at the lower layers, we don't usually separate what's happening physically. So when I get an Ethernet NIC or an 802.11 interface, I don't get to pick my physical layer. It's really bound together. So layer 1 and layer 2 are often tied very closely together. Now, protocols. Protocols are the set of rules that we use to communicate between entities, whether they're hardware or software entities. So there's a structure and an operational set of guidelines for each protocol. Protocols typically operate at a particular layer. So the Internet Protocol lives at layer 3. Now, some will span more than one layer, and that's because we have some interaction between a couple of layers. And then we've got smaller protocols that operate within the context of a larger one. So for example, if you're not running IP, then you're not going to have ARP. Now, equipment. Equipment, like the stuff that you see here, we've got a couple of routers and switches here, also operate at a particular layer because they're usually concerned with a particular set of rules or a particular set of addresses. So routers live at layer 3, they're concerned with IP addresses. Switches live at layer 2, they're concerned with MAC addresses and handling the issues associated with layer 2. Now, some devices, like protocols, span layers. We have multi-layer switches and things like that because they're integrating operations or procedures at a couple of different layers. And here is just sort of a layout of how we map our layers on our devices and some of the addressing. So on the left here we see our TCP/IP model, and then in the middle we've got our devices. Now today we deal really mostly with a subset of these devices. Usually on a network you're not going to see bridges or hubs. You will see switches and access points and routers, and then multi-layer switches that handle switching and routing. Gateway devices, it's a historical term, but we also now see that in voice over IP, where we're communicating between the public switch telephone network and the very traditional SS7 and more modern TCP/IP based VoIP protocols like SIP. On the right here we've got our addressing, and it's really important to remember where these addresses live, because this gives us an indication of the protocols that we need to manage these addresses. So at layer 2 we've got our MAC addresses. That's the 6-byte MAC address built into most interfaces on the network. We've got layer 3 IP addresses, 4 bytes. And then we've got our ports up at layer 2. And these are not to be confused with the physical ports you see on devices like this, but TCP/IP and UDP, or I'm sorry, I'll say it this way, TCP and UDP both use ports to give the endpoints of a socket connection. So those are our important addresses that we have to remember. Now we put the whole thing together. We sort of build a network out of these diagrams. We can sort of see that on the left-hand side we've got the OSI model mapping to TCP/IP model, and that might represent, say, a node here. So the node is integrating and using all of those layers, and then it's connected to a switch somewhere, the network device. And then along the way that connects to a router, and then maybe down to another switch, and then eventually to another node. So at the lowest layers, we're worried about bits. These are the electrical signals, the RF signals going through the air, ones and zeros. As it moves into the network, we have to put it in a container. That's a frame, an Ethernet frame or an 802.11 frame, and eventually that's put inside an IP packet. Devices are concerned with certain layers. So you see here the 2 switches that are indicated. Those are worried about layer 1 and 2. So they're worried about frames and MAC addresses, the local area network protocol like Ethernet or 802.11. The router also has an Ethernet interface, but it's really concerned with processing things at layer 3. So it's processing IP packets. And then eventually you get to the host, and the host has to handle all those things because the host has a network connection, has a MAC address, has an IP address, and then lots and lots of ports that it might be using for its applications. So that's kind of a general way of looking at flow across the network and how all of these things, protocols and addresses and our layers, are integrated together. So here's a packet capture example. You don't have to believe me. You don't have to look at the screen and memorize all those layers. Just look at any packet that you capture on the network. This is an example of a VoIP capture, but you can see that at layer 2 we've got Ethernet type 2. That moves to layer 3. We've got the IP protocol, and then UDP at layer 4, and there's our application or our application data in RTP. So every packet has a certain collection of the layers represented there. Well, I think that'll about do it for this review of networking models and layers. Hopefully you're reminded now of protocols and addresses and some of the equipment and where they live inside those models. Next up, we're going to go to layer 2 for some more advanced topics and push things a little farther in that direction.